Hello folks. This week we are going to be performing an extraction from mint leaves. And so as we're performing this extraction, there are a variety of compounds that we're going to be extracting. Listed here are just some of those compounds. So terpenoids, carotenoids, and chlorophylls. What are all of these molecules? Let's start with terpenoids. You are likely already very familiar with terpenoids, even though the word terpenoid might be brand new to you. Very often, they're cyclic or multi-cyclic compounds. Many do contain some amount of unsaturation, and they often contain oxygen or hydroxyls. Many are aromatic and are components of some types of herbal medicine or traditional medicines. For example, one you're very likely familiar with is menthol. Really, whenever you think mint and you think of that like cold feeling in your mouth that you get, that's menthol. Camphor is another common terpenoid. When I think of camphor, I think of kind of like Vicks VapoRub almost. It's a very pungent compound, very smelly. And then there's the curcuminoids. Probably the most common molecule that I can think of at this moment is one of the molecules in turmeric that gives its kind of yellow color. What about the carotenoids? Now, you probably know about carotenoids. These are very, very common and are closely related to vitamin A or retinol. Oftentimes, when we find them in plants and algae, we think of them as the color-containing compounds. So, right, think of carrots, they're super orange. That's due to carotenoids. Really, the orangey, red, yellowy colors come from carotenoids. Generally, the structures, like the one I've shown here on the slide, very long, conjugated systems. You see that the conjugation extends throughout basically the entire length of this molecule. And because of this extremely extended conjugation, we see color. Let's not forget that when we have some conjugation, we might start getting into like a pale yellow, but as we extend that conjugation, we get deeper and brighter colors. Carotenoids are useful to plants because they can help in the absorption of light. These types of colorful compounds are colorful because they absorb light, and we see what's reflected. Part of that absorbed light kind of goes on to chlorophyll and the photosynthetic structures in plants, because we need light in order to do photosynthesis, and these kind of help with that. Finally, we have your chlorophylls. Chlorophylls are just these massive molecules shown here on the top right. They are very much made of hydrocarbons, but you can also see this central magnesium that is important for that absorption of energy. Particularly, we know that chlorophyll is important for absorbing light energy to pass on that energy to the reaction centers used in photosynthesis. I think chlorophyll's super cool because the way it transfers energy is super interesting. And for the chemists in the room, it does this by a technique called FRET, or Forster resonance energy transfer. Basically what happens is when this molecule absorbs light, it then releases light onto the reaction centers. Now, the wavelength of light that it emits is going to be less energetic than what it absorbed. So it absorbs energy at a certain wavelength, and it emits the energy at a lower energy wavelength. Then the fret happens when that exact wavelength of energy that was emitted is absorbed by the reaction center. I think that's some pretty cool stuff. And actually, fret is used all the time in biochemistry and biology labs. So, of course, the end result of chlorophyll and photosynthesis is funneling of electrons through the electron transport chain. And for plants, that's great because they can make that ATP, they can make that oxygen, and thanks to plants, we can breathe, right? So, how are we going to get all of these compounds? We're going to do it through extraction. And let's kind of walk through the steps of this and the important parts because we don't want any disasters in the lab, and I expect no disasters this week. There are a couple very important things to remember. First, as you build your SEP funnel apparatus, you want to check all those seals before putting your extraction mixture in. If the seals are leaky, you're going to lose your extraction mixture and you'll have to start from the beginning. So what I recommend is put just a little bit of water in that SEP funnel, shake it around, make sure that you don't see any leaking happening before you put your extraction mixture in. What else? Venting. Venting is so important. We'll talk about this in the next slide. Basically, every year that I've done a separation, one student forgets to vent, and they end up being extremely unhappy because what happens is pressure builds up and the solvent kind of explodes at them. You know what happens? Your clothes get covered in nasty solvent and mint extract, and you do not want that. So vent, vent, vent. I'm going to say it again. You gotta vent. Okay. We'll also do a drying procedure to kind of dry the organic layer so that it's just organic without any water. Now, in more detail, how do we do an extraction? So we'll set up our SEP funnel. A SEP funnel is pictured here on the slide. At the top, we have the stopper, we have the body of the SEP funnel, and then we have the stopcock apparatus that kind of lets the SEP funnel open and close. When you're putting your mixture into the SEP funnel, after you've checked that the seals are tight, pour it in with the funnel. We want to get all of that mixture in there, so please use a funnel. Next, when your apparatus is set, it's time to shake and vent. You want to hold one side of the SEP funnel with, you want to hold the head of the SEP funnel, with a stopper very firmly into your hand. You want to make sure that stopper doesn't come off. With the other hand, you can kind of hold the base of the SEP funnel near the stopcock. You want to shake vigorously about 3 times. And by vigorously, what do we mean, right? We want to see that the mixture inside is mixing thoroughly. Okay? Shake, shake, shake. It all mixes. Immediately after, you want to hold the SEP funnel just like it's in this picture, with the liquid at the bottom and the stopcock with no liquid next to it, and we vent. So then we open the stopcock and release pressure. Okay? This is absolutely necessary. While you're releasing that pressure, make sure not to point it at anyone. Once in a while, enough pressure has built up that a little bit of your solvent will spray out. So make sure to point it maybe kind of at the bench so that if it spurts out, it just goes onto the bench and not your lovely partner. Then repeat that a couple times. Shake, 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 really vigorously, vent. Close it. Shake, 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 vent. Close it. Then your separation will happen beautifully. Now, after you're done with the shaking and venting, you'll basically put the separation funnel right side up. You let the layers separate, and then you'll kind of let each layer leave the SEP funnel separately. Make sure you know the densities of your solvents this week because you want to know which layer is which. Now, after we separate our organic layer from our aqueous layer, we want to dry out that organic layer so there's no more water in it. So we'll be using drying agents, magnesium sulfate, sodium sulfate. They're great because they'll absorb all the water left in your organic layer. And the process here is, a little bit slow. You'll have your Erlenmeyer flask with the organic layer in it. Add that drying agent bit by bit and do a gentle swirl. You'll see that in the beginning, basically you'll add the drying agent and it'll clump and stick at the very bottom of your Erlenmeyer flask. You want to keep adding that drying agent and swirling bit by bit until you see that that drying agent is no longer sticking and clumping at the bottom. Generally, what this means is that you'll do a little swirl and you'll see that that drying agent is kind of just like floating around like sand rather than clumping at the bottom. When you've hit that point, you're done. This week, I got to make sure to prepare you some additional stains that we've never used before so that we can see some of the beautiful compounds that we've extracted. One stain that I'll prepare is N-acetaldehyde. This is great for functional groups that have nucleophilic properties. Oftentimes, terpenes are pretty good at this. They have some of those nice hydroxyl groups. We also need to heat with this stain to kind of allow that nucleophilic attack to happen. Where is the attack happening? Well, folks, I'm seeing one potential electrophilic site in this molecule. What do you think it is? Now next, we're going to make a secondary stain for some of these plates. We're going to run a couple different TLC plates, so make sure to read your protocol carefully. We're going to run a ceric ammonium molybdate stain, again with heating. This stain reacts with all sorts of molecules and all sorts of functional groups, and generally, depending on the functional group it's reacting with, it'll turn a slightly different color. So that's kind of cool, and hopefully we'll be able to talk a little bit about that as well. Finally, folks, what are our green chem moments of the day? The first, use a catalyst, right? When we use catalysts, we're lowering the activation energy of the reaction. So potentially, we don't need to add heat or perform the reaction under pressure. This makes the reaction more green. When this semester have we used a catalyst? Nearly every week. And then secondly, design for degradation. We want any chemicals that we are synthesizing to be more or less biodegradable. If they get into the environment, we want them to kind of degrade and be non-toxic. We don't want them to be sticking around for millions of years, contaminating our environment. Think this week about how these potentially apply to our separation. We're not doing a reaction, so catalysts doesn't apply, but maybe design for degradation does. And that's it this week, folks. I leave you with your mint-related cat meme.